Hello. Okay. Good afternoon, everyone. So I think we will start today's session. Just can anyone just confirm that my mic is audible to you all? I am audible to everyone, right? I request everyone to mute themselves. So if anyone just can confirm that my voice is audible, you can type in the chat section to confirm also. Am I audible, right, guys? Anyone please just confirm once. Sandeep, Reena, Nikita, Mohammed, Mubarak Musa. I am audible, right, to you all?
I'm on my way to my
Sorry,
uh,
I
uh,
got one yes from
uh,
Reena that I am audible. So I hope that that goes for everyone else in the meeting. So we'll start today's session basically. So let me share my screen. So this screen is also visible, right? You may unmute yourself. Please feel free. Anyone just the screen is visible. I want to hear you.
Yes, ma'am.
Yeah, thank you. This was Nikita. Okay, so basically, I'll introduce myself. I am Adyasha Sahoo, your TA for this course of Power System Engineering. So basically, the course you will be studying, like for the past 1 week, you may have watched the videos, right? Recorded videos of Professor Debapriya. And uh, this first week will be having 5 videos for you, right? So after watching those videos, in each week, we will be summarizing the content of the week. Like for today's session, we will be summarizing the content of the 5 lectures for week 1. So basically, since all the theory part is covered in the lectures, recorded lectures, so we'll just have a brief overview of those theory and we'll be focused more on solving the problems in real time. Okay. So I want a two-way interaction so that any one of you must feel free to interact with me. Please unmute yourself and we'll be having problem solving in an interactive manner. So for that, I need your support whenever I ask. So prompt and please like take the initiative to talk to me or answer back to me. So that way it will be more helpful to you only. So have you all watched the video of lecture 1 to 5 for week 1? If not, anyways, we'll be now summarizing this. Okay. So, any doubts for anyone, or shall we proceed? Any query regarding the sessions or anything? You can ask now, then we'll proceed towards the overview of week 1. Any confusion or any doubt in your minds? Okay, so let us proceed now. So basically, the outline is we'll first have a brief overview of the content of this week's, followed by question and answer session. Basically, we will be solving the problems, or there will be multiple choice questions. We will discuss those questions, followed by any doubts of your, we'll be clearing that. So this week was basically focused on insulators, right? So can anyone tell me which type of insulators we started with in the course? Or what is an insulator at first? Anyone? What is the need of an insulator? Just in your words, one or two words. Anyone would like to answer this? See, if you want that, if I only talk, that is already happening through the recorded videos, right? This is a live interaction, so make use of it. And this live will factor will come into play only when you interact. Otherwise, anyways, there are recorded videos of Professor Debapriya, and that way of learning you have already done in the past week. So now it is the time that we interact with each other and learn. And this is not an exam, we just are interacting through this. Okay, so feel free and try to just answer anything. It can be. So what is the need of this insulator? So basically, we need this for supporting our line conductors, right? Our transmission lines or distribution lines to support the conductors and to as well provide separation between them, right? And separation between them. So, what are the characteristics of these insulators? What are the desirable characteristics? Any one characteristics? Anyone? The screen is visible, right? Anyone? Regarding its permittivity or dielectric strength, anything? Miss Reena, Nikita, Sandeep, Selva, regarding its permittivity, what do we require? It should be high or low for the insulator. Mubarak, Musa, What should be the permittivity of the insulator material? Okay. See if okay if you don't speak anyways. So it should be of high permittivity, right? So high permittivity. And why we require this to be high? So that it can withstand higher amount of stress. Then what about the next characteristics? It should be having, what about dielectric strength? The dielectric strength of the material, insulating material should be, it should also be high. And the reason for it is because we need to withstand high overvoltage occurring. And why this overvoltage basically occur? First is that it should be able to withstand higher overvoltages occurring in the system. Then moving forward, why at all these overvoltages are occurring in our system? Anyone? There are two major reasons for these overvoltages. They are, anyone? Firstly, due to the external factors, right? Due to the lightning or thunderstorms that are occurring. So that may strike the insulator, which will cause high voltages. Secondly, is due to the transient overvoltages due to the line switching, right? Transient overvoltages due to switching. Then what next? For 33 kV lines,
Low permittivity.
sorry, anyone?
Hello?
Yes,
Low permittivity.
conductivity,
Permittivity.
permittivity.
Yes.
Permittivity is high, we discussed, right?
Okay.
Because we need to withstand higher amount of stress that are occurring, right?
Then high mechanical strength.
Yeah, high mechanical strength also you can say that is also one of the desirable features.
Yes.
Yes,
Then
thank you.
non-inflammable. The inflammability is none, is zero.
Inflammability,
Yes, is
what
zero.
what is that characteristics basically mean? What is,
Hello?
yes, I can hear you.
What did you say?
I said that you said about the characteristics of inflammability, right?
Yes.
So what is the meaning of this characteristics? Like, what does this mean?
Something that is easily to be burnt.
Yeah. So basically, it should not react, we can say, react with the atmosphere.
Yes. Yes,
So,
ma'am.
so it should be a inert, we can say basically inert to the gases that are in the atmosphere. So basically, whenever it will interact with them, then only it can lead to other byproducts of that reaction, such as this inflammable inflammation or any other chemical reactions which may lead to cracks in them. So basically, they should be inert materials. They should not react with the moisture and the atmospheric gases because the insulator it is suspended in the air. So basically, it can interact either with the components that are present in the air, basically the gases that are present in the air, or whenever it rains, or inherently the air is also carrying some moisture, right? So there are two enemies we can say for these insulators. Firstly, the atmospheric gases. Secondly, we can say the moisture. So if the insulator is inert or it is chemically inactive due to the interaction due to these features we can say, then our material is perfect. Otherwise it will lead to corrosion of the materials or erosion, or we can say process will take, they will develop cracks and all. Ye- okay, I hope this is fine. Thank you for actually volunteering and giving the answer. So we'll next, I was asking
You are
that for
welcome, ma'am.
Thank you. So basically, next I was asking that for voltages of 33 kV, which type of insulator do we prefer to use?
Sorry, I can't hear you. I can't hear you.
Is it audible or not?
I can't hear you, ma'am. What did you say?
For 33 kV insulator, sorry, conductors, line conductors, what type of insulators
Yes.
should we go for?
Port insulator. Three port insulator. Each carrying 11 kV.
Pin insulator, right?
Yes.
Yeah. So basically, we had studied that they are like of different type of insulators, one pin, two pin, or three pin. So in the broad category, they
Three,
come under this
three
pin
pin.
yeah. And
Three
what,
pin port.
yes. Then what about 66 kV?
Six. Six.
Uh, No, we can't. If you have gone through those lectures, it is maximum up to three pin type we have. After that,
Okay.
we move to a different type of insulator, not the pin category. The pin category is up to one type, one pin, two pin, and three pin type insulators.
Okay.
When we move to 66 kV, the insulator type is now changed from pin to another else. So if you can recall that,
Disc.
yeah, this called suspension type insulators basically.
Yes. Okay, suspension.
Suspension type insulators. So here we had basically let me the characteristics we had high permittivity for withstanding high. Just a second, let me allow someone. Okay. Yeah, so I was summarizing the characteristics of these insulating materials that we want, desirable characteristics. So they were high permittivity for withstanding high stress, then high dielectric strength to withstand high over voltages, which may occur due to either lightning or due to the switching transient over voltages. Then third, we said it was high mechanical strength, right? And then moving on, we said that it should be chemically inert to the gases and moisture present in the atmosphere. Okay, here I can see Reena has said that it is used to protect us from dangerous effects of electricity. So basically, we can say not dangerous, basically to facilitate the transmission of electricity to our homes. So thank you, Reena. And you can also unmute yourself and speak. So I may miss your messages sometimes. Feel free to unmute yourself and interact. Okay. Then we had fifth was anyone else? We want to minimize the leakage currents, right? And why we want to minimize these leakage currents?
To reduce losses.
Yeah, so basically these are not useful for us. So this will flow in through the earthing basically back. We don't want that. We want that it should be transmitted to the lines towards the receiving end. If there will be large leakage current, basically there will be more losses in the system. And it can also then lead to more leakage current means they will interact with the neighboring communication lines. So you know that wherever we have power conductors, so nearby we may have some also communication conductors, and both of them are having electricity. It will also produce a magnetic field, and when this will come in interaction with the communication lines, so there may some interference may take place through between this power and communication lines. So with this leakage current, this interference will increase. So hence we want to minimize this leakage current to minimize the losses as well as to minimize the interference between the power and communication lines. Yes. Then high resist, yeah, chemically inert and high resistance to temperature. These we had discussed. Anyone else? Any other characteristics? Okay, then we'll move on. The next thing we'll be discussing is puncture voltage versus flashover voltage. So, will anyone want to unmute and speak anything about this flashover, puncture? What about the relation between flashover voltage and puncture voltage? Which one will be greater?
Puncture is greater.
Okay, just a second. So, flashover and puncture. So, one vote goes that puncture voltage is greater. Anyone else? Anyone else?
No, madam.
So, all are agreeing that puncture voltage is greater than the flashover voltage, right? Okay. So, why, uh, on what characteristics basically these two voltage depend? The puncture voltage. will depend upon the thickness of the insulating material, right? Yeah, so as we were discussing, the puncture voltage will depend upon the thickness of the material. And what about flashover voltage?
Leakage current amount.
Okay, one answer says leakage current. Flashover voltage, right?
Yeah.
Yeah. So anyone else? Yes, rightly said. It is leakage currents. And anything else? Okay. So to prevent this leakage current, what precautions we take? Basically, two precautions we take for that. One is
Length, increasing the length of the arc.
increasing the length of the arc, right? For that,
Yeah.
basically what structure changes we make for the insulator? We add something to protect it from the dust or rain, external quantity.
Semi-galvanized,
Yeah, so
semi-galvanized coating.
mm, yes. So semi-galvanized coating for protecting against the dirt and dust, right? Or we say it semi-glazing. Similarly, for moisture, for rain protection, what we do? We go for rain shades, right?
Yeah, petticoat.
Yeah, rain shades or petticoats. Okay. So what this will help to do is basically it will create a equipotential surface on the surface of the insulator. Then, okay, next we will discuss about suspension insulator or so these are in the form of strings, right? So what are the advantages of using this suspension type insulator in the form of string? Anyone?
Swing is reduced basically between conductors.
Here, are you sure? I'm talking about suspension type insulator where you have basically you have discs.
We can remove and replace discs when needed.
Yeah, rightly said. So if you can remove any, let's say one disk is damaged, so you can just remove simply that one disk and then the whole string can function as it is. And similarly, if you can remove, then you can also add when needed. Let's say now the load has increased for which you need more strength of that insulator. So basically, you can add the number of disc in the insulator, and you know need not to go for a separate whole new insulator. Only adding one component will be able to withstand, right? Okay. And what else? Someone was saying about something like wind or something. Basically, they are free to swing. Then next type we had strain or tension type insulator. And where they were used, anyone? Whenever we required uh,
At edges.
at edges, right? When they are basically when there is a change in direction or when there is a termination of the line or termination or end point of the line, we can say. Okay, and next what we had, next type we had V string. So they are used in the case of high voltage transmission lines, right? Then there was a comparison between porcelain and glass depending upon their different characteristics. After that, we had studied about how there is the voltage distribution in the insulator, right? So basically, we had a structure like this. So this each capacitance represents one disk, and here we have the transmission line. So what was the problem here? Anyone can. So do we have equal voltage distribution across these three disks or three capacitors?
No.
And why? And which one is having higher or lower? Let's say this is 1, 2, and 3. So V1, V2, V3, which voltage is greater? It is in the ascending or descending, anyone?
V3 will be the max.
Yeah, V3 is the greater and V1 is the less. But why so?
Because the conductor line is directly connected to the V3. Then
Yeah,
after that it will
and
go to V2 and after that V1.
yes, and we have this earth leakage capacitance also, right? Due to this effect, we have unequal voltage distribution through this disk. So for that, what we do, we have methods for equalizing these voltages. How we do that?
Grading, capacitance grading or shield, static shielding.
What happens in capacitance grading?
Different capacitance is used means for insulators.
Yeah, so basically if this is C1, C2, C3, so in capacitance gradings, basically they will not be equal. By certain calculations, we will determine what value of capacitance should be used to equalize those voltages. But since it will, what is the challenge faced here is for manufacturing process, these will not be available, right? Manufacturer for this disk will be having one or at max two types of disk of two capacitance value. So for that, we are not going for capacitance grading in the practical. We are going for static shielding. And what happens in static shielding? Anyone?
Capacitance is added to the disk near to the line and bottommost.
Yeah. Basically, externally, we add one this type of. So this capacitance is added externally, which tries to equalize the leakage current. So this current, leakage current, should be equal to the current flowing through this external static shield. So for by that way, the current that flows from this C3 will be equal to C2 will be equal to IC1. I hope till now it is clear, so that we may go for Q&A. So which of the following statements are true or false? You have two statements here. Insulators are always used in tension. Pin insulators are only used in voltages up to 33 kV. First, we'll discuss this. Pin insulators are always used in tension. So, who all are going for true and who all are going for false? Anyone? For first, pin insulators are always used in tension.
False.
Okay, one false. Anyone else? Anyone else would like to answer? What about second? Pin insulators are only used in voltages up to 33 kV.
True.
True. Okay, one true. Anyone else?
True.
Two votes for true. Anyone else? So, anyone else would like to attempt this? So, it was rightly said. The first statement is false, and the second is true. Okay, next, the use of strain insulators can be observed at dead ends at any intermediate anchor tower on straight runs, either A or B. Which is the correct one? Anyone? Okay, Sandeep Kumar Verma is saying A and B. Anyone else? One vote for A and B. C. Muhammad Shah Nawaz Alam says C. You can unmute yourself, you can write in the chat. And I request everyone to be ready with their calculators. After this, we'll be solving problems. Any other response? So the correct answer is yes, it is A and B. We discussed, right, at the termination points or when there is a change in direction. So the correct answer is either A or B. Then we have a question here. So it is saying that consider a three-phase 50 Hertz 12 kV distribution system. Each conductor is suspended by an insulator string having two identical porcelain insulators. The self-capacitance of the insulator is 3.5 times the shunt capacitance between link and ground. Find E1, E2, and string efficiency. So if we draw the structure here, so how many discs are there? Two, right? Everyone got the question? 12 kV. So 12 kV distribution system, and it is suspended using a string type insulator having two insulators, and the self capacitance is 3.5 times the shunt capacitance. So I have two string type insulators, and it is said that self capacitance is 3.5 times shunt capacitance. So what is the relationship between C1 and C2? Is C1 equal to 1.5 times C2 or C2 equal to 1.5 times C1? Which one is correct, first or second? Anyone? Sorry, it was 3.5 times. Sandeep Kumar says second one. Anyone else? So one vote for this. C2 is 3.5 times C1. This is C2. So I am saying that the self capacitance is 3.5 times shunt. So which one is the self capacitance here? C1 or C2? Anyone? Which one is the self capacitance here? These are the insulators, right? So C1 is the self capacitance here, and this is the shunt capacitance, C2. So I am saying that the self capacitance C1 is 3.5 times shunt capacitance C2. So this is right. Is it clear? Then what we have been asked here, the voltages E1 and E2, right? So for that, what we need to do, anyone? We will write the KCL equation. What does the KCL equation state basically, anyone? KCL law, Kirchhoff's current law. Anyone? What is Kirchhoff's current law, anyone? This must have been a part of your basic electrical course, right? Please speak up. Find current I1, I2, and I3. That will do eventually, but right now what I'm asking is what is KCL? What is the Kirchhoff current law state? Sorry?
वेट करें
Sorry, who was speaking? Algebraic sum of all currents is zero. Yes. So basically, at a node, where? At a current node, the total currents incoming is equal to the total outgoing currents, or basically the sum of all the incoming and outgoing currents are zero. So basically, by that law, we can say here I1 is equal to I2 plus I3. Yes. So what can we put in place of I1 here? I1 is equal to E2 times J omega C1, which is basically 3.5 times of C. And what about I2 and I3? I2 is E1 J omega again C1, basically 3.5 times C, plus I3 will be, what is the voltage across this? It is same as E1 or E2? Voltage across C2? E2. You can unmute, it will help me. See, this node is common here. Now this point and this point, they are at equal potential, right? Because here it is insulated. So the voltage across this node A and B, which is same as this node B, will be equal to E1, right? I hope it is clear. E1 j omega times. If it is not clear, please ask, because this equation you will be using throughout this course for all problems. This only this KCL you need to learn to write. E1 times j omega times C2, which we are taking as C. So from this, what is the relation between E1 and E2? Anyone? Anyone? What is this ratio? What is this? 3.5 by 4.5. How much are you getting? This will be 0.78 times C2. And E1 plus E2 is, the voltage is given as 12 kV, right? 12 kV. So E1 plus E2 equal to 12, or E1 plus E2 equal to 12 upon 20, root 3. Anyone? Which one is correct? Anyone? Sandeep Kumar says E1 is 1.285. I'll check. No, I don't think so. Second one. Why second one? So you are saying E1 plus E2 equal to 12 upon root 3. So yes, second one is correct. So what is this in decimal? Anyone? 6.928. Thank you. So let us round it. 6.93, let's say. Then if we substitute, then you get here this E1 as 0.782. So 1.78, E2 is 6.93. So I get E2 as 6.93 upon 1.78. 0.78. I get 3.89. And then I get E1 as this into 0.78. So is this fine, everyone? This is the final answer, right? So as usual, you got higher voltage near to the line conductor. This one E2 and E1 was less. Then what about string efficiency? It will be anyone? What will be the formula first? What is string efficiency? Total voltage across the string, that is E1 plus E2 divided by number of insulators. We have two insulators here, multiplied by voltage of the insulator near to the line. So in this case it is E2. So calculate this and tell me how much it is. Anyone got the answer? Yes, it is 88%. Okay. The next question. A string insulator has 4 units, then 40% of the total voltage is voltage across the bottommost unit. Then find out the string efficiency. Please calculate it and tell me. String insulator has 4 units and 40% of the total voltage is voltage across the bottommost unit. What is the string efficiency? Anyone? So this is the question that you need to solve, those who have joined now. String insulator having 4 units, 40% of total voltage is across the bottommost. So what is the formula for string efficiency? It will be total voltage, right? Across all this insulator. That is, let's say, the total voltage is V. So it is V upon how many insulators are here? 4 times voltage across bottommost insulator here. So that is given 40% of total voltage. Means this is 0.4 times of V. So this will give me how much? Anyone? In percentage, so multiply by 100. Anyone calculated? Nikita, Aishwarya, Ritesh, Srihari, Dipendra. So this will come out as 62.5. Yes, 62.5, Srihari, you're correct. Thank you. Then moving on, next question. In string in a string of suspension insulators, the voltage distribution across the different units of a string could be made uniform by use of a grading ring because it forms capacitance with link pins to carry the charging current from link pins, forms capacitance which help to cancel the charging current from link pin, increase the capacitance of lower insulators unit to cause equal voltage drop, decrease the capacitance of upper insulator unit to cause equal voltage drop. So here we are talking about static shielding. So which one will be correct? Anyone? By use of a grading ring means this is static shielding, right? So how in static shielding the voltage distribution is made uniform? So this is my grading ring. So due to this grading ring, capacitance is formed here, this capacitance. So how it is equalizing the voltage? Mm, Out of A or B, one will be correct, right? Because it has nothing to do with the capacitance with the insulators. Because you are not changing the capacitance of the insulator here, but you are adding a external capacitance due to this grading ring, which will do what? Will it carry the charging current from the link pins, or it will cancel the charging current from link pins? So let's say the current direction is this way. So basically it cancels the effect of charging current from the link pin. So this current will anyway flow, this leakage current you can say, but the current flowing here through this grading ring, it will help to cancel this charging current. So the correct option is option B. These two are not correct. A is not correct. Is it clear? Okay, the next question. The ratio of capacitance between pin and earth to self-capacitance is 0.25 for a string insulator with 2 units. If the maximum voltage across any unit should not exceed 10.5, find maximum voltage that the arrangement can withstand. Anyone? So, self-capacitance is C1 or C2? Anyone? This is earth here. Which is the self-capacitance here? C1 or C2? Someone says C1. See, C1 is the capacitance between this is earth. So basically this is your earth, this is your pin. So C1 is the capacitance between pin and earth. This is C1 between pin and earth. Self-capacitance is the capacitance of the insulator. By the name itself, it is saying self. Means this insulator itself C2. Okay. So it is saying that C1 by C2 is equal to 0.25. Right? And then again, what is the second relation? That the maximum voltage across any unit should not exceed 10.5. So we know that the voltage across this C2 will be greater than this one. The lower insulator will have greater voltage. So basically, our constraint is that this V2 should be equal to 10.5. Right? If I am saying this is V1 and this is V2, So V2 is 10.5. Then find the maximum voltage that this arrangement can withstand. So again, we have to just write the KCL here. So basically here this incoming current is V2 j omega C2, that is equal to V1 j omega C1 plus V1 j omega C2. So from here we'll get it as V2 C2 equal to V1 C1 plus C2. So from here, if I divide by C2, I get V2, or let me divide by C2, okay. V2 equal to V1 C1 by C2 plus 1, right? If C1 by C2 is 0.25, then C2 by C1 will be 4, right? So this will become 5 times V1. So you know V2 is 10.5. So V1 is V2 by 5. This will give it as 2.1. So the maximum voltage is V1 plus V2, which is 12.6 kV. Is it fine, everyone? Any doubt here? There is a mistake here. Anyone? Can you find it? Here C1 by C2 is required. I had put here. So this is 1.25. So this will be V1 is V2 by 1.25. So what will be this V1? 8.4. This will be then 18.9. Is this clear? This is the same KCL equation which we'll be writing always. If you have any doubt, you can ask me, I'll explain again. Every question you just need to write this KCL equation and the given data, whatever condition is given, you need to put and you'll get the answer. Yeah, Srihari Naik, V2 was 1.25 V1. Thanks for correcting me. Then next question. So this is the final answer. The next question. The occurrence of puncture of an insulator can be lowered by increasing the thickness of insulating material or increasing the resistance to leakage current. Which one is correct? Okay, Dipender says A, Dipender Singh Parmar. Anyone else? Anyone else? Yes, this is the correct answer. By increasing the thickness, we can decrease the puncture voltage of an insulator. Okay, the next question is, I have to type it, just a second. Next question is, if the puncture and flashover voltage are 125 kV RMS and 62.5 kV RMS, what will be the factor of safety? So, anyone? The puncture voltage and flashover voltage are given. So, what will be the factor of safety? So, what is factor of safety? Is it puncture voltage by flashover voltage, or is it flashover by puncture? Which one is correct? 2 or 1? Anyone? VP by VF, first one. Srihari Naik says first one. Yes, it will be punctured by flashover. So this is wrong. So what will be this ratio? I think it is 2, right? I'll type the next question. I hope this was clear. Okay, the next question is each conductor of a three-phase overhead transmission line is suspended from a cross arm of a steel tower by a string of four suspension type. By a string of four suspension insulators, the voltage across the second unit is 12 kV and across the third unit is 16 kV. Calculate the ratio of capacitance between pin and earth to the self capacitance of each unit. What does this safety factor signify? Basically, the higher this, if you remember, the puncture voltage was that voltage at which the insulator will be completely destroyed. So, whenever there is a puncture voltage, after that, Mr. Sumit Kumar, so are you in this meeting? Are you attentive? If you're talking to someone else, you may leave the meeting. I don't need any disturbances here. please switch off your video and leave the meeting if you are not interested. But don't do this disturbances. Don't create disturbances here. Thank you. So basically what I was saying that yes, so flashover voltage will be occurring regularly in the system, and whenever a flashover voltage occurs, the insulator will not be completely destroyed. It can withstand that. But whenever there is a voltage above the puncture voltage is there, the insulator will be completely destroyed. So basically we are trying to say that we are how much margin you are keeping. The more is a safety factor means the more margin you are keeping for puncture voltage, right? For the insulator. Let's say if I keep 50 times higher, this will basically signify the design of the insulator. Higher the safety factor means that insulator is more robust to any puncture voltage violations that will take place. So is this clear, Mr. Dipender Singh Parmar? Okay, thank you. So moving on, we'll see the next question. So in the next question again, here we are given with four insulators, right? Okay, so let's say these are C1, these are C2. So it is asking the ratio between pin and earth, capacitance between pin and earth is C1 by the cell capacitance is C2. So we are asked this ratio and we are given the voltage, this V2 and V3 is given to us. So let us see. So for point P, if I write the KCL, it will be C2 or basically V2. It is V2, sorry, V3. I'm writing for point, so this one. V3 j omega times C2 is equal to this one. So what will be this voltage? This will be V1 plus V2. So V1 plus V2 j omega C1 plus this part. So this will be V2 j omega C2. So by this we'll get the relation here, that is V3 C2 equals to V1 C1 plus V2 C1 plus C2. Similarly, at the junction Q, when we write the KCL, it will be V2 j omega C2 will be equal to V1 j omega C1 plus V1 j omega C2. So from here I'll get V2 C2 equal to V1 C1, V1 times C1 plus C2 basically. And we know the value of V2 and V3, right? So substituting that, your V3 is 16. So 16 times C2, V1 is unknown. So I will put here 16 times C2 equal to V1 times C1 plus C2. And here 16 times C2 is equal to V1 C1, V1 C1 plus V2 is 12 times C1 plus C2. So I need C1 by C2. So dividing this by C2, I'll get 16 equal to V1 by C1 by C2. Let's say this is M, is M plus 1. So here also, let me divide this by C2. So again, 16 equal to V1 M plus 12 times M plus 1. So from here, this equation you can see I am having only variable as M. So from here, M and V1, there are two unknowns. So from here I get V1 as 16 by M plus 1. So 16 V1 is 16 by M plus 1 times M. So M is come here plus 12 times M plus 1. So if I, so this will give you a quadratic equation, right? So this will be 16 M plus 1 equal to 16 M plus 12 times M plus 1 square. So you can solve this equation, quadratic equation, 12M square, 16M will cancel here, 12M plus 2M, 24M, 24M plus 12, and here this will come, so this will be minus 4 equals 0. Let's take 4 common here, so 3M square plus 6M minus 1 equals 0. So what will be the roots of this equation? Anyone? 3M square plus 6M minus 1. So by solving this equation, you can get the value of M. quadratic equation. Okay. And I have the next question. I'll type here. Just a second. Okay. Any doubts, anyone? You can ask now. So after this, I think you need to submit the assignment one. So any of you has officially like registered for the examination of this course for the certification purpose basically. Is anyone of you? So today's class was clear to all. Srihari, Nikita, Aishwarya, Deepender. Okay, one of you have registered for exam. So Pallavi, okay, Deepinder Singh. So I think what is the deadline for assignment? Are you aware? For this week's assignment must be live, I think. 7th of Feb. Okay, so I think these questions that we discussed today, they will help you in your assignment. So submit those assignments timely because they will also carry some marks, I think. So it will help you. And okay, thank you, Srihari, for the feedback. If you have any feedback for me from the next class onwards, any suggestion you want, so we can do that. Any changes you want, or any doubts from the session. So basically for the insulator chapter, it is very simple. Only that KCL equation you need to understand, like what voltages you are writing, which capacitance it is asking, and after that it is very simple. Only those two equations you have to just write the KCL at 1 point or 2 point, and solving that using the data that is given in the question, you will be able to get the answer. So this is quite simple for you. So we are having remaining 10 minutes. If anyone wants to interact, ask anything not related to this course, maybe related to electrical engineering, your department, anything you want to know. If not, then I think we may close the session for today. Is it fine? Shall we proceed to closing the session? or we have 10 minutes. If you want to ask anything, you can ask now. So are you, some of you are, I think, BTech students, right? So myself, I am doing my PhD from IIT Roorkee in electrical engineering. My specialization is in power system engineering. So any input you want to know, anything you want to know, you may ask. Whatever, according to my knowledge, I'll try to help you out. And try to speak in these sessions because already you are having the recorded video lecture where sir is explaining very nicely. The only thing is that that is not live, that is recorded. But since this session is live session, you should try to take the most of it because again, if you don't speak anything, it will be just another recorded session for you. Okay, then I think we will close for today's session. The video recording, this will that of today's session, it will be presented in the YouTube link of my channel. You can find it there, and the slides also I'll be posting in the drives. So you can, if you want, you can go through those. So we'll close this session then for today. Thank you all for joining. And again, next Saturday, 3 to 5 p.m., we'll be discussing week 2 content. So you may leave the meeting if you want, if you don't have any query. Thank you. Thank you, Shreyari, for joining. Thank you, Dipendra, Aishwarya, Nikita.